Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of Keam Prep, we are going to be looking at some questions asked in Keam 2020. So this is our third video on the series Keam Prep, and we are discussing questions of the Kerala Engineering, Architectural and Medical Examination. So in this particular exam, you'll be asked questions of various subjects such as physics, chemistry, and mathematics, and so it's best to prepare for them by looking at previous year's papers. So here we have a question from Keam 2020 from physics. A disk spinning at the rate of 27.5 radians per second is slowed at the rate of 10 radians per second squared. The time after which it will come to rest is 2.75, 5.5, 1.25, 3.5, and 6.2 seconds. So, how do we solve this question? Well, we know that omega 1, that is the initial angular velocity, is 27.5 radians per second. And the final part of this question gives us the information that omega 2, which is the final angular velocity, it will be equal to 0. We also know that the acceleration here is equal to 10, but since it's slowed down at the rate of 10 radians per second squared, the acceleration is negative, so it's minus 10 radian per second square. And now we need to find out the time period. Well, we are going to use the equations of motion in rotational kinematics. So these equations are the same as those you can find in in linear kinematics. The only difference is you're replacing the velocity and acceleration with the terms from angular velocity and angular acceleration. So the first equation is what we're going to use here, and that first equation is omega 2 equals omega 1 plus alpha t. So basically, omega 2 stands for final angular velocity, omega 1 stands for initial angular velocity, alpha stands for acceleration, t stands for time taken. So from here, you can write omega 2 minus omega 1 as equal to alpha times t. So therefore, time period is equal to omega 2 minus omega 1 divided by alpha. So now we put in the values. And so when we put in the values, you'll get t as equal to 0 minus 27.5 divided by minus 10. So therefore, you get minus 27.5 divided by minus 10. So both the negatives get cancelled, so you get 27.5 divided by 10. So the time period is equal to 2.75 seconds. So the time period it takes to, stop a disk from moving at 27.5 radians per second to 0 at an acceleration of minus 10 radians per second square will be 2.75 seconds. So therefore, the correct answer among the following will be option A, 2.75 seconds. Let's look at another question. 4 particles of masses m1 equals 1 kg, m2 equals 2 kg, m3 equals 1 kg, and m4 are placed at the 4 corners of a square. The mass m4 required so that the center of mass of all 4 particles is exactly at the center of the square is 3 kg, 4 kg, 1.5, 0.5, or 2 kg. So, first things first, we know that these 4 particles are arranged in the 4 corners of a square. So let's draw a square. And now we have 4 masses attached to the 4 corners, and this is 1 kg, this is 2 kg, M3 is 1 kg, and M4 is M4 kg. Now, we are going to assume that the center of the square will be the center of the coordinate plane in which the square is present. So therefore, the coordinates of M1 will be x comma y, the coordinates of M2 will be x comma minus y, the coordinates of M3 will be minus x comma minus y, and the coordinates of M4 will be minus x comma y. So, we are going to assume that the center of mass is exactly at the center of the square. So that means at the center of mass, the x coordinates and the y coordinates of the point of center of mass is 0. So our condition is that the position of center of mass, both its x coordinate and y coordinate, is equal to 0. Now, since XCOM equals m1x1 plus m2x2 plus m3x3 plus etc. divided by m1 plus m2 plus m3 plus etc. So basically, it's summation of I is equal to 1 to n mixi divided by summation of I is equal to 1 to n mi. So for this particular question, the x coordinate of the center of mass is 0, and our values will be 1 kg times x plus 2 kg times x plus 1 kg times minus x, and then plus mass of the fourth corner times minus x divided by 1 plus 2 plus 1 plus m4. So therefore 1 times x and 1 times minus x cancel each other out, so you have 2x plus 2x minus m4x divided by 4 plus m4 as equal to 0. We take the denominator to the right hand side, and it will still be 0, so therefore x times, that's 2x minus m4 times x equals 0. It means that 2x will be equal to m4 times x, so the x's get cancelled, which means that the mass of the fourth corner, of the mass of the object at the fourth corner, will be equal to 2 kilograms. So 2 kg is the correct answer. So among the following options, it is clear that option E, that's 2 kg, is equal to the answer that we found out. So that is the correct answer for this question of physics, which was asked in Keam 2020. The basic idea is to use a square and then ensure that the center of mass is the origin point of the coordinate axes, which is imaginary, that we made. So once we know that the coordinates here is 0, then we can easily find out the value of that remaining mass. Let's look at some questions of chemistry. In which one of the following reactions entropy decreases? So the question here is, what is entropy? Well, entropy is what we call the measure of a system's unavailable thermal energy. Now, usually when you have energy, you divide it into two phases. On one side, energy is used to do work, while on the other side, energy is used to change the system. So that the second type of energy is what we call entropy, and it can also be defined as the measure of randomness. So let's look at the following options. Which of these reactions result in a decrease in entropy? So option A, sodium chloride is dissolved in water. When sodium chloride is dissolved in water, it dissociates into ions in water. And then these ions, they move about and they become more random. So therefore, option A is incorrect. Option B, water is heated from 303 degrees Kelvin to 353 degrees Kelvin. More heat means you get more energy, and when you have more energy, the entropy is more, so that means it's more random. Water becomes more random, water molecules. So option B is incorrect. What about option C? Sodium bicarbonate is decomposed to Na2CO3, CO2, and H2O. This particular reaction is exothermic, and an exothermic reaction releases heat, which means that the system becomes hotter, which means it becomes more random. So therefore, option C is incorrect. Now, what about option E? Dihydrogen molecule is decomposed into hydrogen atoms. Well, H2 now turns into 2H. So therefore, it requires an enormous amount of heat to break the bond between the two hydrogen molecules. So that means more heat, which means more random. And also, you can think of it this way. You have twice the amount of, twice the amount of elements inside the system, and these elements are also unstable, so they start moving around and they become more random. So option E is incorrect. The correct answer is option D, water crystallizes into ice. So this occurs at 0 degrees Celsius, which is 273 degrees Kelvin. So at this stage, water becomes solid, and solid items have less entropy. So therefore, option D is the correct answer for this question in 2020. Now, the next question. The standard enthalpies of formation of H2O and CO2 are minus 286 kilojoules per mole and minus 394 kilojoules per mole, respectively. If the standard heat of combustion of CH4 is minus 891 kilojoules per mole, then the standard enthalpy of formation of CH4 is minus 75 plus 75 minus 211 plus 211 minus 1571 kilojoules per mole. Well, we have the standard enthalpies of formation of H2O and CO2 given. So a good idea is to start from there and, find and use the equation for the formation of CO2 and H2O. So C plus O2 gives you CO2, and the enthalpy of formation here, that's delta H, is minus 394 kilojoules. For H2O, it'll be 2H2 plus O2, which gives you 2H2O. So delta H will be 2 times minus 286. So 286 times 2. 6 2 is a 12, 8 2 is a 16, 16 plus 1 is 17, 2 2 is a 4, plus 1 is 5. So, which is minus 572 kilojoules. And finally, you have CH4 undergoing combustion. So that means CH4 is reacting with oxygen to form CO2 plus 2H2O. Now, this reaction has delta H equal to minus 891 kilojoules per mole. Now, in order to proceed for this question, we will need to invert the third equation. So this is not the third equation. The third equation is inverted. And that equation is CO2 plus 2H2O gives CH4 plus 2O2. The delta H for this particular reaction is 891 kilojoules. Now what are we going to do? We are going to add equations 1, 2, and 3. So, what do we get? We get C plus O2 plus 2H2 plus O2 plus CO2 plus 2H2O. And on the right-hand side, you get CO2 plus 2H2O plus CH4 plus 2O2. So, well, O2 plus O2 gives you 2O2. So, that gets cancelled. And CO2 and H2O are present on both sides, so both of them gets cancelled. What we have left is C plus 2H2, which will be CH4, which will give us CH4. So we now have the equation for the formation of CH4. All that remains is to find out the standard enthalpy of formation. So for that, we will be, adding up all of these enthalpies, standard enthalpies. So minus 394, minus 572, plus 891. So you have 394 plus 572, giving you 966, and then 966 minus 891. 6 minus 1 gives you 5, 16 minus 9 gives you 7, and 8 minus 8 gives you 1. 8 minus 8 gives you 0. So 75 is what we get, but since the signs are inverted here, so the correct answer for delta H for this particular reaction is minus 75 kilojoules per mole. So the correct answer for this question is minus 75. And if you look at the following options, you can see that option A, minus 75 kilojoules per mole, is the correct answer. Now let's look at some questions of mathematics. The domain of the function f given by f of x equals root x minus 1 is minus infinity to infinity, 1 to infinity, which is open, closed interval 1, open interval infinity, closed interval 0, open interval infinity, open interval 0 to infinity. So, how do we solve this question? Well, the first thing to note is that we will assume f of x is real. And so for f of x is real, for f of x being a real function, its domain and range must consist of real numbers. Now, if we were to plug in some values, for example, if you plug in 1, if x equals 1, then under root of x minus 1, that is under root of 1 minus 1, which is under root of 0, which is 0. So 0 is a real number. But if you were to take x equals 0, then it'll be 0 minus 1, under root of 0 minus 1, which is under root of minus 1, and this number is not real. It's what we call the iota, or the imaginary number. So, now we know that any number which is less than or equal to 0 cannot be present in the domain because it makes the range complex. So therefore, the correct answer for the domain of the function has to be option C, closed interval 1, open interval 0. So the reason being that if you plug in 1, you get a real number, but if you plug in 0, you are not getting a real number. This is imaginary. So therefore, option C will be correct. Option B states that 1 does not include in the domain. which is wrong. So option B is incorrect. Option A is incorrect because it goes from minus infinity to infinity. All, negative numbers are not included here. And then open interval 0 to infinity is incorrect because we checked out 0. It's not giving us a real image. And option E is also incorrect because, well, we tested out 0 and it's an imaginary number. So the correct answer is option C, 1 to infinity. Now, let's look at the final question of this episode. Let A and B be finite sets such that n of A minus B is 18, n of A intersection B is 25, and n of A union B is 70. Then find out n of B. Well, this question is based on sets and SETS. So, how do we solve this question? First, we're going to use the formula for A minus B. N of A minus B can be written as n of A minus n of A intersection B. So basically, A minus B is this particular portion. So you have the whole set A, and you you subtract the value, the number of elements which are common from this set, and you get A minus B. So n of A minus B is n of A minus n of A intersection B. So n of A minus B is 18 equals n of A minus 25. So n of A equals 18 plus 25. And when you do the addition, 8 plus 5 gives you 13. 1 plus 2 plus 1 gives you 4. So therefore, n of A equals 43. Now, since we know that n of A equals 43, we are going to use this value for finding out n of B. So n of A union B will be equal to n of A plus n of B minus n of A intersection B. So therefore, you'll get n of B as equal to n of A union B plus n of A intersection B minus n of A. So n of B can be written down as A union B is 70 plus A intersection B is 25 minus n of A, which is 43. So 70 plus 25 gives you 95. 95 minus 43. 5 minus 3 is 2. 9 minus 4 is 5. So therefore, 52 is the correct answer. That means option A is the correct option among the following for this question. So that concludes this episode of Keam Prep. If you want to access our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have a whole lot of educational content, and that includes mind maps, which you can use to refer the chapters which come in Keam. So if you want to access those, you can hit the playlist in the description box down below. If you want to access more of our Keam lessons, then don't forget to hit the playlist for that, again in the description. So until the next webisode, take care, stay safe, bye-bye for now.